Math in 3 with Mrs. Z. This video is about graphing polynomials. It's an introduction to the correlation between the graph and the equation. This video is about graphing polynomials. The general shape of the polynomial gives some hints on what the equation of the polynomial looks like. From the graph, we can determine multiple things about the equation. So looking at this first graph, the first thing that I notice is that my two endpoints are going in the same direction. They're both headed in the negative direction. Here's one, here's the other. When endpoints are headed in the same direction, that means that you have an even function. Since both endpoints are headed in the negative direction, the leading coefficient is also negative. This graph has one turning point. It's at the top of the graph here, so we have one turning point. The turning point is one less than the degree of the polynomial. So we know that this is a quadratic. The highest exponent is going to be 2. Roots and zeros come from when the graph intersects with the x-axis. Remember, your x-axis is your horizontal axis. Okay, it's this one. The horizontal axis intersects twice with our graph. It intersects once here and it intersects once here. So we have 2 roots. End behavior is just determining what direction is the end of the graph headed on each side. Correlates very closely with talking about the domain of the graph. So the left-hand side of this graph is headed to negative infinity. The right-hand side of the graph is also headed to negative infinity. Let's take a look at graph number 2. In graph number 2, the end are both pointed in the same direction, this time positive. So we have an even function, and we know that the leading coefficient is positive. There's one turning point. That leads us to know that this is going to be a quadratic, since the number of turning points is one less than the degree. Number of roots are zeros. This graph crosses the x-axis twice, so that lets us know that there's going to be 2 roots or solutions. The right-hand side of this graph is headed up to positive infinity. The left-hand side of the graph is also headed to positive infinity. All right, 2 more examples. So in this graph, we can see that the end point, one points down and one points up. They're headed in opposite directions. That leads us to know that this is an odd degree function. The overall graph is starting out low and going up high. I like to sometimes draw a linear equation right on top to show that movement. That's a positive movement, starting low, ending up high. That lets us know that the leading coefficient is positive. Here we have a turning point, and we have a turning point on our graph here. That's 2 turning points. That lets us know that this is a cubic, x to the 3rd, because our turning points are one less than the degree of the polynomial. We should have 3 roots. This root right here is a double root since it just skims the x-axis, and this root right here we can tell is x is equal to -4. So that lets us have 3 solutions to this polynomial. On the right-hand side of the graph, we are headed up to positive infinity. The left-hand side of our graph headed to negative infinity. One more just to show you kind of all the possibilities that you could have. So this graph, endpoints are in opposite directions. That lets us know that we have an odd degree function. The overall feel of this graph is starting up high and headed down low. That lets us know that our leading coefficient is negative. Number of turning points, there's one here and there's also one here. So we have 2 turning points. The degree is 1 more than the number of turning points. So this is a cubic function. That lets us also know that there are 3 solutions or roots or zeros to this polynomial. On the right-hand side of the graph, we are headed down to negative infinity. On the left-hand side, headed up to positive infinity. And that's how we can get information from the graph of a polynomial about the equation of the polynomial. This was Math in 3 with Mrs. Z. Please like and subscribe below. Thanks!